To start with, I'd like to begin the way I like to start most things in life, with a bad joke, just to set the tone. And because we're in Berlin, Germany, it's going to be themed. Are you ready? It's so stupid. The other day, I deleted all of the German names from my mobile phone. Now it's hands-free. Thank you, DroidCon. See you next year. Oh, Lord. Just so you know what to expect, because that's about as good as it gets. Welcome to Practical ADB to enhance your life. That's a clickbaity-ass title. I am really going to try and do my best to fulfill the promises of said title. Just before I begin, a little obligatory audience participation. Raise your hands if you use ADB from the terminal regularly, daily, weekly. Ooh, good. You're in the right place then. Raise your hands if you find ADB useful. Okay, good, good. For those of you who put your hands up, I'm hopefully trying to build on that a little bit and give you some more practical ways of using a little bit lesser known and quirky ADB stuff. And for those of you who didn't put your hand up, I'm hoping to flip you into the hands up variety. Anyway, who am I? I am an egotistical maniac. Well, by the photos up on the screen, I definitely am. My name is Ben Kadel. I'm a principal platform engineer for Android at a company here in Berlin called Babbel. We make like a language learning app. You might have heard of it. I love Git, the terminal, and for some reason Bash. I had far too much free time and got really obsessed with those things. Also, selfish plug, you'll see this a lot throughout my slide deck. I have my very own YouTube channel where I do really stupid, like, tech-codey tutorial-y things. So if you enjoy this nonsense, maybe check that out, if you want. I'm not your dad. Oh, goodness, throwing it at my screen there, that's fine. Up on the screen there on my socials, please feel free to reach out to me or just barrage me with, I'm not going to finish that. It's a HR problem. All right. Possibly you're sitting there thinking, oh, I've heard it all before. ADB talks where the presenter does 1,001 weird ADB commands and is like, right, see you later, good luck with that. I don't want this talk to be like that. I really want to focus on the practicality of using these things. So I'm going to focus on 3-ish, very slim slices of ADB and how you can actually pick it up and use it in your day-to-day Android development. And the proof of it is that I use everything that I'm about to show you daily, at least. And the other side of it is I want to give you a little bit of Bash and terminal knowledge as well, so that combining the two, you become an ADB wizard. Now, for those of you who grew up the same time I did, you're hearing a little audio track in your head. Right? And the rest of you are like, quick, get out of here. It's not too late. Let's go. Anyway. This is going to be a I show you the door kind of presentation, and you must walk through it yourselves. Yes, I'm going to sort of show you some very particular things of ADB, but most of all, I want to sort of show you the basics, how to use it, how you can apply it, and then sort of give you the space to continue your learning on your own if you'd like to. So everything you see in this PowerPoint, in this deck, is in a link, in the link tree. So this link here is the glorious golden link. Please, if you forget everything else from this talk, just remember that link, and the QR code takes you to that website, I promise. And the first link in the link tree is to this slide deck, so feel free to take photos if you like. Just make sure I'm in it, like this. Tag me on Twitter. But if you don't, that's fine, because you can get the deck yourself. I'm wasting a lot of time with fluffing. Here's the agenda. Quick introduction to ADB. It's not supposed to be an introduction to talk, but I do want us all to be on the same page. Then, there's 3 main big chapters that, as I said, focus on a very thin slice of ADB. And the last chapter right at the end there is a miscellaneous, extra bits. ADB weird commands, just because it wouldn't be an ADB talk without it. So ADB, or Android Debug Bridge. The first thing to know, very important, that across the internet, there is zero consensus about what the logo should be for ADB. So here's a couple. Pick your favorite. ADB lets your machine and your device communicate to one another. Of course, it does a huge range of things, like uploading and downloading files to and from the device. You can shell into your phone. We'll cover that later. And screenshots, recordings, and much, 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 much more. Okay? It's included as part of the Android SDK in the Platform Tools directory if you're looking for the executable. But you can, of course, install ADB without installing Android Studio, just in case you didn't know that. And of course, Android Studio, under the hood, uses ADB for a bunch of stuff. Hopefully, none of this is new. Here's some of the usual suspects. And by usual suspects, I mean the boring, very basic ADB commands that you've seen 1,000 times over. Many times before, we're not covering any of those. We have to go deeper. Sorry. I get too much power with this mic on my face. Anyway, we're not doing the basics or introduction stuff. If you are brand new to ADB and you would like an intro to, then of course I have a video on my YouTube channel covering exactly that, including installation of ADB and how to get developer settings set up to talk to your phone. Plugs, 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 I'm sorry. However, you use ADB, whether you're aware of it or not, all the time if you're an Android dev. But I believe the power of ADB is super underutilized in the ways that we use it. So I'd like to show you some other weirder ways. However, important, I am not the authority on ADB. I'm simply an idiot with a mic and a clicker and a stage. Silly DroidCon. However, there are many more people out there that are far smarter, better, cleverer than I is on ADB. So here's just a couple of links in case you really want to dive into some really juicy ADB stuff. Some great videos and articles, some wonderful people, including people that actually contribute to the ADB project, in case you're interested in the history or the context of why ADB is, or you want to learn about the internals and how it works. Great stuff. Again, links in the link tree. As the great Alice Merton once said, I got no roots. Yeah, sorry, I don't know the rest of the words, that's it. It's a really stupid way of me saying that everything you see in this slide deck has been done on a device that is not rooted. Most of the things you'll see could have been made 10 times easier on a rooted device, but I'm crazy, and I like a challenge, and I don't want to root my device. Did you know, however, our physical devices that we hopefully all have, they come with root access disabled by default. Of course, you can root your phone to get access. But emulators, they come with root access enabled by default. So if ever you need to do something rooty and you don't want to root your device, try an emulator. Chapter 1. Automated input flows. Here's one of the first chapters. For each of the chapters, I want to give us like a little problem statement, like hey, we're Android developers and this thing sucks, so how could we solve it with ADB, right? A carrot and stick sort of implementation. So here's the problem for automated input flows. As developers, we often have to do these mundane, monotonous tasks over and over again. For example, logging into our apps to get to the screen that we're actually implementing or testing. It takes time and effort, and it's unnecessary, because it could be automated. So here is the idea. Why don't we use ADB to create a fast, reliable tool, maybe a script that can automatically do those things for me, like logging me into the app without me touching the device? Carrot deployed. Look, man, no hands. ADB can send input events to your device. Hopefully you're aware of that. If not, then it can send all sorts of events as though the user has done that thing. For example, taps, licks, click, headbutts, booty wipes, whatever. I don't know what it is. All sorts of weird input, it can do it, right? Here's what an ADB command for input would look like. You'll see this notation throughout the slide deck. This is basically me saying, hey, here's an ADB command, and most of the time you can copy and paste it. So it's ADB, obviously, the keyword, shell, which again, mental post-it note, we're going to come back to that bit later. Then input, because we're doing an input thing. And then we need to fill in what kind of input we're doing. If we wanted to do a tap, as though the user had taken their finger and touched the screen at coordinate x, 100, and coordinate y, 100, then that would be the event. So we've seen taps passing x and y. We've got swipes, where we pass a starting x and y, a finishing x and y, and the duration that it took for them to swipe from the start to the end. This is also how we do long presses as well. We just don't change the ending x and y. We've got text input, as though the users popped up the keyboard and started typing, and we've got hard and soft key events like the volume button, or in this case, the home button. So we can do all sorts of crazy input with ADB from the terminal without touching our phone. But let's go back to the example. We wanted to automate a login flow. So we need to do a bunch of taps. We maybe need to click some buttons, right? Let's try and find the coordinates for something on screen. Let's take this really awful rudimentary login form. It's not even a login form. I'm tricking you, but anyway, that submit button there, how do I find the coordinates for that button? Well, I could do ADB shell input tap 100, 100, and then see if it hit the button. If it didn't, change it to 100, 200. If it didn't, change it to 100, 300. No, come on. There's a better way. In the developer options, we can toggle on this pointer location setting. When we toggle that on, we get this sort of moving crosshair that follows our finger as we move it on the screen. And along the top of the bar is an updating X and Y that tells us where our finger currently is. So we take our finger, move it over to the submit button, look at the top bar, and we're like, that's my X and Y. Nice. There's a problem here still, though. Right? I had to touch my phone to go to the developer options to toggle on the pointer location. No. There's a better way. In fact, there's an ADB command for exactly that. This is a copy and pastable ADB command. I won't read it out. Pointer location 1 turns that setting on, and pointer location 0 turns it off. There's a bunch of other settings you can mess around with. I'll let you discover that on your own. But there's still a problem. I'm so lazy. I'm so lazy. That was a long command to either copy and paste from somewhere or to type. So instead, I'd like to set up a bash alias. And if you don't know what an alias is, please don't worry. It's basically me telling my system, hey, I'm giving a nickname to this long-ass command. So instead of ADB shell settings, blah, 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 point location 1, it's now, for me, PL and enter to turn the point location on, and PL and off to turn it off. Nice. Laziness for the win. Anyway, we now have the capability of finding a single node's coordinates, its x and y. But what happens when we have a login flow, multiple screens that we need to chain together to automate that? We have to do clicks here, clicks there, text input, et cetera, et cetera. So I'm going to give you 3 options now, and they're going to get progressively better as we go, but I want to try and tell the story of it, where we are going to use a bash script, or a shell script, to do this for us. Now, please do not panic. A script is basically just a file with multiple lines, and each line is its own terminal or bash command that triggers one after the other. So in this script, you can see I'm doing inputs with hard-coded x and y's, and sleeps between them, and a sleep is just like a thread.sleep. It's just wait. Hey, let the next screen load, and then I'll do the next tap. Okay? This has, obviously, hard-coded x and y's for my UI components on the screen. I trigger it in the terminal, and it works. It's fine. It works until it doesn't. Because the phone that I've written this script for is a Pixel 6, and I've been developing with my Pixel 6. And this script works great on the Pixel 6, but then the moment that it's not a Pixel 6 anymore, it's a Pixel 4 with a different resolution and a different size, those hard-coded x and y coordinates no longer point to the same place, and my login script falls down. Boo. So I bring you to option 2. We're getting better and better. I'd like to introduce you to something called UI Automator, which is actually part of ADB. It's used mostly for UI testing, but we're not going to go into that rabbit hole. We can use the power of UI Automator to sort of responsively find our coordinates for us. When we use the command ADB shell, UI Automator, and dump, what it does is it takes a sort of snapshot of my phone, the screen in its current state, the UI elements that I can see, and dumps it out into an XML format, something that I can then programmatically work with, right? So if we've used dump as the screen in this state here, there's that maybe later button in gray. Somewhere in my massive XML tree, there's a node that has the text, maybe later. That's my button. So we can take that XML output, and then we can use other programs like grep, cut, and sed to sort of search through it, parse through it, find that node with my matching string, and then find this bounds attribute that sits right next to it. And this is just rectangle bounds. From left to right, it's the top left corner in x and y of the rectangle, followed by the width, followed by the height. And there's my views rect. Ooh. With a little bit of very basic maths, we can find the dead center of said rect, which gives us an x and y coordinate, and hopefully you're following along with me. We can take that x and y coordinate and plug it into our tap command. And now we have found our UI elements and got the coordinates without hard coding them. Tasty. Gets better, don't worry. Quick sidestep, this way. ADB shell UI Automator dump, that command we used, by default, it dumps that XML to a file on the device, which is weird, right? Because likelihood is I'm running my login script from this beauty, from my host machine. I'm going to be parsing it and then triggering other ADB commands from this. So if the data is on the device, I need to take it somehow. So I could use ADB pull to say, hey, give me that file to my host machine, and then that's fine, that works. But that's 2 commands where 1 would have been sufficient. And with a very quick change to the original command, instead of shell, we use exec out, we can get that output, instead of to a file on the device, we can get that file right back to us on our terminal in front of us, or captured in a variable, like you can see below, in a script. Nice. Okay? The exec out thing, by the way, I would like everybody to take a little mental post-it note and just put it in the corner of their minds for exec out. Because I know it's like, oh, exec out, what? But I'm going to explain that later. We're going to come back to it. Mental post-it note. Cool. So back to option 2. Let's say in our script now, we want to get rid of the hard-coded values. We've got a bash function called getCoords, and it takes one string, the string of the view element that we're trying to find. It could be remind me. It could be maybe later. Inside of that function, this is very, very theoretical. Don't worry, I'll come to implementation later. Inside that function, it does a UI Automator dump. It does all the parsing. It finds our string, it finds our node, finds the bounds, and spits out x and y coordinates, which we can then pass into the tap command. Cool. Again, we trigger it from the terminal, and it's much better, and it works. There's one problem still. UI automated dump by default is slow as hell. Now, I'm being super overdramatic. Slow as in it takes 2 or 3 seconds for it to do a dump, but 2 or 3 seconds, it's like a lifetime. So we need something better. And I'd like, oh yes, and especially when you have multiple screens, and for each screen you need to do a UI automated dump, 2 or 3 seconds adds up, right? Because you need to dump every time the screen changes so that you're capturing the exact state of the screen. Nightmare. I'd like to introduce you to option 3, the best option, the final one. UI Automator 2. This has nothing to do with Android. This is actually a Python wrapper that wraps the vanilla UI Automator, and you can install it with pip on your machine. It's called UI Automator 2. And it's basically, it does some fancy footwork, some black magic under the hood that calls UI Automator but makes it somehow really instant, like really fast. I don't know. So theoretically then, in our bash function getCoords, anywhere that we called UI Automator, we switch it for UI Automator 2. And this is a copy and pastable Python snippet that calls UI Automator 2 instead of UI Automator. And then the response is rapido, right? Again, I've talked a lot of theory here. I've not shown you any actual code for that getCoords function. I could put code up on the screen, but that's a waste of everybody's time. So in the link tree, there is a gist called tap node if exists. It should have been getCoords, but I didn't marry the two up in time. So it's called tap node if exists, and it's the actual code for that getCoords function that you can copy and paste straight into your setup and use. It uses UI Automator 2, and you can pass it a string and so on. Okay? You can check out the code just to see how it works as well. Cool. So when I run it, it looks like this. This has not been sped up. This is me logging into the Babel app. It's a looping GIF, so it might not start at the start. It's just on my table. I've not touched my phone at all, and it's lovely and fast and rapid. But there's one more problem, in my humble opinion. I've had to type in login.sh enter, which is a nightmare. We can do one better. Maybe we can set up a keyboard shortcut to trigger the script for us, and we can do that using the power of something called Automator, not to be confused with UI Automator. Automator is a tool that's likely installed already on all of your Mac machines. If you're a Windows user, you have my permission to fall asleep for the next 30 seconds. The next 2 slides showcase how you can do that keyboard shortcut setup. I won't go over it too much because you can just get the slides and follow this instructional guide. But the first thing is we need to create a service from our script. We can do that in Automator, Quick Actions, and Apple script that points to our bash script. And then we have a service that we can trigger from somewhere inside our Mac. And then in System Preferences, Keyboard Shortcuts, we want to trigger a service. And you can see that my services, this is the bit that caught me out a little bit. The services I created are in the General tab for some reason. So if you can't find your service, check that tab. And you can see I've got a couple of services, Clear Babel, Login Babel, Start Babel. You can set a keyboard shortcut there. And then, oh, no terminal, just function Shift F10, and the thing just opens for me. And I can do something else. Oh, it's amazing. Magnifique. OK. That was chapter 1. That was the big, long one. Now they're getting a bit more shorter and concise. So if you've fallen asleep, wake up! I'm sorry. They're not going to invite me back. I don't blame them. Dump sys. Get all the infos. Here's the problem statement. Often, we can't be sure exactly what's happening behind the scenes for our app. We think we know because we coded it, but I thought I inflated a fragment, but I'm not seeing anything on the screen. Did I inflate a fragment? Or I thought I set an alarm in Alarm Manager, but nothing went off. Did I set that alarm? Well, why don't we use a tool called dump sys, which is awesome, to quickly get information about all manner of things happening under the hood on our device, and specifically about our running app so we can debug and understand it better. And I said, hey, what's going on? Please don't leave. Please. I don't have any friends. I'm sorry about that. I just had to do that. It's for my own entertainment. It's a really stupid way of me saying that dump sys is as though it's He-Man, Master of the Universe, asking the Android device, hey, what's going on? It's a diagnostic output for all system services running on the device. Now, that's a huge ballpark to play in, but it's really useful because it tells you the truth, what's really happening. Information about all sorts of things, running activities and fragments, batteries, alarms, blah, 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 blah. The list goes on. The services that are part of dump sys are huge, and I will let you find them out for yourselves, but there's a couple on screen. Here's the ADB command, ADB shell, dump sys, and then the service we want to query. For example, if we want to find all of the alarms that are set on the device, it's dump sys alarm, and it tells us the apps that have set the alarm, for when they'll go off, and the pending intents that will trigger. We can get battery information. Is it charging? At what percent is it? We can get information about packages by passing a package ID, things like version numbers, permissions, etc. And we can get information about background jobs that are scheduled. Okay, shit. I need to pretend like I'm presenting. Everyone pretend I'm presenting. You can get information about background works that are happening, and this is really useful if you're working with Work Manager at all. Job Scheduler will tell you the jobs that are scheduled and for the constraints for when they will trigger. Very, very cool. But the service I want to focus on is the activity service. And this tells me information about a running app on my device. We pass it a package ID. It gives me all manner of information, such as the task that encapsulates the activity, the activities that are active and running, the fragments that are active and running, the fragment transactions that have happened, the view hierarchy dump, like, oh, there's a text view inside a linear layout. It tells me information about the view states. Is it paused, resumed, started? It tells me information about the object references, if it's the same object as it was before, if it's been recreated, and much, much more. And it's really easy to read, see? Right? Cool, see you later. No, it's a nightmare. It's really long, and in fact, I got bored already. I did 3 scrolls, and I was like, oh, no one will know. I took the screenshots, but it's really long, and it's complicated. But it is useful. The information in there is the truth, and it's useful. So I want to do 2 things. One, I want to give you a very brief introduction about how that structure of the output was. In the case that you want to read the output for yourself, you at least know where to begin. And 2, I want to give you a tool that does all of that for you and passes it into a nice prettified output. So, number 1. Here is a very, very oversimplified, rough structure of that output for the package ID that I give it. Indentation is everything here. Indentation denotes, obviously, child-parent relationships, right? So you can see at the top we've got a task, and that's the task that encapsulates all of my app and some information about it. We have activity blocks that each contain information about the activity, the view hierarchy dump, the fragment and the fragment managers and the child fragment managers all the way down, and then backstack information. Please look at the indentation. That is everything. That's the best place to start. Okay? So that's a rough idea of how to read it, but here's one better. There's a tool called Easy Dump Sys, which is essentially a glorified activity dump sys parser. It takes this nasty, nasty output and turns it into this. Propagates quick information that I believe is the useful information, at least it was for me. It tells us about the activities that are active, the fragments and their hierarchy in a visual format, the active fragments with their object references and class references. For me, I find it's a really useful tool. I do a lot of code reviews for code challenges for hiring. And for me, I'll run their app, and I'll run Easy Dump Sys and see what's really going on under the hood. And it's also a really great tool for diagnosing. That fragment example I gave you before, like, oh, I thought I inflated a fragment, but I'm not seeing anything. Easy Dump Sys will quickly say, yeah, there's no fragment there, idiot. Get a different job. And finally, little sidestep here again. Under the hood, I just want to say this, by the way. Under the hood, Easy Dump Sys uses a tool called fzf. And the only reason I'm saying that is for later. We're going to talk about that later. I just wanted to say fzf, so later you're like, oh, I said that earlier. Oh, my God. OK, good. If you hate tools or hate your precious time, then, of course, you can search the output for yourself using a tool called grep that's installed on all your machines. You pipe the output of dumpsys into grep, and grep is just a string searcher. It says, hey, is there this substring as part of that input string? And grep will say, no, not there. Or grep will say, yeah, it's there. It's on this line, and return the line to you. So, for example, you could grep for activity, capital activities like that, and you'll find immediately from the output all the activities that are there. You could search for a specific item view from the view hierarchy dump. Whatever you want, you can search for it. The reason why I'm telling you about this is because with grep, you can actually append one of 3 letters to it to enhance the output, A, B, or C. And this will basically give you the matching line that has been found with extra lines depending on the letter. So A is lines after the matching line, and you give it a number, so 3 matching lines including the matching line. Or B, that amount of lines before the matching line. Or C, a combination of A and B, or context, or around, I don't know. So one of those letters and a number behind it. And the reason this is useful, let me give you an example straight away. That activity one, capital activity, will tell you the activities that are there and active or whatever, but it won't tell you the state. The activity state, if it's paused, resumed, or whatever, is actually 2 lines beneath the activity line. So if you hyphen A and 2, you'll get that information as well given to you for free. Tasty. Ladies and gentlemen, I'd like to bring you a quick selfie break brought to you by Budweiser. No, I don't know. I shouldn't be. I always forget to take selfies with the crowd, and this is an awesome crowd. So I'm going to take a selfie now, and I hope that's OK. So do a stupid face or hide your face or whatever. But I build it into the slides because I always forget. Ready? 3, 2, 1, say selfie! Yeah, okay, cool. All right, come on. Back to work now. Jeez. All right, here we go. Chapter 3. Thank you for doing that, by the way. I appreciate it. Look, Mom, on stage. What does your app know? Here's the problem statement. Again, we can't exactly be sure what data is locally stored on the device about our app. We think we know, but we can't exactly be sure. And in order to find out those answers, we have to do some amount of effort to get that answer. It'll be clearer in a second. So here's an idea. Why don't we use ADB to let us quickly see and alter the information that's stored locally on device for our app, in our app's internal storage. Oh, exciting. So what am I talking about? So as I said, things are stored on device. In order to see those things, we often have to intercept them as they're being transacted, maybe with a breakpoint or even changes to the code, print lines to see what the data is, or whatever. All of these things require effort, time, maybe even build time, and it's not needed. The things I'm talking about, by the way, just to be really clear, things like shared preferences, files that are stored for your app locally, and database contents, like room database. In order to really describe this topic and help explain it, I need to take a step back and explain ADB shell. Remember we had a little mental post-it note earlier? Let's pull that out and let's go to it. ADB shell, the command, will let you, without any other parameters after it, shell into the phone. It's as though I've left my terminal and I've stepped into the device and I'm now doing commands and all the hacky stuff inside my phone. Yeah. And when I'm ready, I can exit and I can come back to my terminal. For those of you who are smarter than I is, it's like you've SSH'd into your phone, essentially, if that helps. But we have seen this shell command with stuff after it in previous examples. What's the difference? ADB shell without anything, the top one, will give you this lingering interactive shell session that you can do whatever commands you'd like in it and then exit to your heart's content. Whereas ADB shell with a command after it will do said command as though it's in the context of the device itself and give you the output. Okay? And then it will exit and there's no more session. But we talked about exec out as well. That's a bit weird. What's the difference there? Again, another mental post-it note. Take that. Throw it away. ADB shell versus exec out. Remember, with the UI automated dump, we just changed that like one word, and it changed how it reacted. What's the difference? Let me explain. We have a phone plugged into a laptop. When we did ADB shell, UI automated dump, with a file name. By the way, the dump command can take a file name, and it will store the XML dump into that file name. And I can't do namings very good, so it's called file. I'm sorry. So when we do shell, it dumps it to a file on the device. But when we change that to exec out, with everything else the same, it dumps it to a file on our host machine. And you can basically just think of exec out as though it's picked up all of the output and written it to a file on our host machine, as opposed to the device itself. And that's why that line before worked, because we're writing it to this dev tty file. And if you don't know what that is, that's a Unixy Nix thing. Basically, if ever you write to this file, it will write the contents that you've written right back to you on screen or right back to you in your script. Okay? So that's hopefully given a little bit more explanation about exec out and the differences. Sort of shell is like within the phone and its context there. Exec out is take it and do something with it in the context of our host machine. Okay, right. Back to the objective. We're trying to find data inside our phone. So let's go into our phone, ADB shell, and I'm inside the device. Okay, I know that my app's data is stored somewhere in the /data directory. So let's cd into there. Let's look at the things that are in it, and permission denied. Okay, no worries, no worries. Don't ask me how I know this, but I know the full absolute path for my app's internal storage. It's here. Let's cd into it, and permission denied again. This is a good thing, by the way, although right now it's a bit of a pain in the ass. It's great, because if any app or any Joe Blogs has the permission to just look at your app's internal storage or even edit it, that would be utter chaos. Would not want to live in that world. But for us, the app's authors, the app's developers, we can sidestep this problem using a wonderful command called runAs. Whilst we're in the shell, if we use runAs and give it the package ID of our debuggable app, that's really important, debuggable app, it's as though we've said to the system, hey, let me pretend I'm the app. Let me see the phone through the eyes of the app. And it'll be like, oh, yeah, here you go. And it will CD me directly into our app's internal storage location. I will become a slightly different user temporarily. And I can see and manipulate all of my app's internal storage. There, those are the files. Those are the folders that make up my app's internal storage. Cache, databases, files, shared prefs. They're right there. Just as a quick note, all of those locations have API that maybe you've seen before when you're writing your apps. For example, the files folder right there, we can write to and read from using context.filesdir. That is the path that we're seeing right there. That's the folder. That's the one when you use context.filesdir to read and write. Oh, interesting. So let's take shared preferences as an example. let's try and have a look at the shared preferences. Shared preferences are stored in XML files inside of that folder, and we can use the cat command to basically dump out the contents of the file whilst we're running as. So if I do that, sorry, it's weird. There's our shared preferences. I'm seeing key value pairs. Email is Ben at Ben. Last login is some timestamp. We're seeing the contents that's stored on the device. We're sure of it. But those of you who have been keeping up with me, probably thinking, oh, can we edit that and see what happens to our app? Oh, yeah, we can. Strap yourselves in, here we go. Let's edit some shared preferences. The first problem to tell you is that on a non-rooted device, we haven't got access to a text editor like Vim, Vi, Nano, Ed, or if you're a monster, Emacs. And the other problem is that we don't have the permissions to just directly pull that shared preference file down onto our host machine, edit it, and upload it. But with a little fancy footwork, a combination of run as and a program called sed, we can do exactly that. Now, sed, just as a little caveat, is a stream editor, and you've likely got it installed on all your machines as well. It takes one form of input, like hello world, whatever, and it runs some manipulation on it, a sed program. So, for example, change all the E's to A's, and then spits out how it would look. So hello world turns into hello world. Sorry. Yeah, no. Anyway. By default, sed does not overwrite the incoming stream. So if you gave it a file, sed wouldn't overwrite it. It'd just say, hey, this is how it would look if you made those changes, and then sort of looks at you funny. But we can use the -i flag to say in place, which says to sed, yeah, overwrite the files. I'm crazy. Do the manipulation and then overwrite it. So whilst we're running as on our system, we can use sed with the -i flag, pass it our shared preference file, and then give it a sed program, like the one in single quotes here. Now, sed programs are this whole other talk, not for now, but this one, just for ease of use, basically changes every instance of the word Ben to Tim. So we change our shared preference file, and the email Ben at Ben would become Tim at Tim. Fine. We've done it. We've changed some shared preferences, but probably everyone's a little bit deflated because that took a lot of effort to do that, right? That sucks. And it's also very, very dangerous, because if Ben is anywhere else in that shared preference file, that nasty sed program will really cause some trouble. So I am a giving person. I would like to gift some tools instead. And the reason that I'm gifting this, obviously, is so you can use it directly, but more so you can look at the code, see how it was done, and maybe write something yourself as well if you wanted to. Two things here. The first one's a repo called prefedit, and it gives you like an interactive shared preference editor in the terminal. It says like, hey, here's your shared preferences. Oh, you want to change that one? Well, here's the old value. Here's the new value, blah, 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 right? Or the one beneath it is a gist, is the one I much prefer. It pulls down that shared preference file to your host machine. You can edit it in your favorite editor to your heart's content, and then with a little bit of fancy setting, it re-uploads it back to the phone with the right permissions. Cool. Again, links to all of these in the link tree. It's more so that you can see the implementation. I'm not trying to just like promote my own crap, because these are garbage. Okay, chapter 3 is done. We're almost there, everybody. There's not a clock, doesn't matter. We're now at the I've got the 10-minute gesture. Excellent. This is perfect then. This is the miscellaneous, the extra bit. The commands that I couldn't categorize, and it wouldn't be an ADB talk without it. I've got 4 little categories, each taking about 2 minutes, and we should hit home perfectly. So let's dive in. First, fzf. Remember, we talked about it before? I want to talk about it properly now. fzf has nothing to do with Android or ADB. It's a terminal-y tool. It's a command line fuzzy finder. What the hell does that mean? Basically, I can give fzf any multi-line input. For example, here I've given it cat, hat, bat. I've piped that into fzf. I said, here, take that. And fzf does this really interesting thing. It populates this rudimentary sort of graphical user interface in the bottom left corner of my terminal with each of those options broken down. I can use my arrow keys to select one of the options, or I can start typing to autocomplete, or at least remove the options that don't contain those letters. Very cool. And when I hit one, or when I select one or more of those options, the output of the fzf command is simply the option that I've selected, and I can then do with it what I will. If that was a little bit too much, please don't worry. Sorry, again, selfish plug. I have a video on Introduction to fzf on my channel. Please check that out if you're interested in that. But the one thing that I wanted to talk about with fzf, back to the Android sort of context, is this. fzf, anytime you have a list of things, and you need to select one or more of those things, fzf is perfect. For example, if you've got more than one device plugged in, you often have this issue where ADB complains, it's like, I don't know which device to run it on. What if we plugged fzf into that system so that instead of complaining, the system says, hey, you've got more than one device, pick one. And then you pick one, and it pipes that device's ID, or whatever it is, serial ID, to the correct command. Very cool. Here's copy and pastable code. It runs the device's command, cleans it up a little bit, passes it to FZF, and then takes the output and passes it to the shell command in this case. Interesting. What about another example? Terrible example. We can use the package manager, or PM, to list applications that we've installed, third-party apps, on our device. We can pipe that list into FZF, and we can select one or more of those things and maybe give it to the ADB uninstall command, or we could clear up all of the local data stored for those apps, or whatever you want. FZF, awesome. Just remember it. Love it. I'm not on commission. I should be. Number 2, screen size manipulation. This is a bit of a strange one. There's a command, ADB shell WM for window manager and size. When you trigger that, it reports back to you the physical resolution of the device. But what if I pass a new resolution to that command, WM size with a new resolution? It actually morphs and changes your screen on your physical device or your emulator in front of you, matching the new constraints. Ooh. There's also a density command, WM density, which reports back to you the DPI. What happens if I pass a number to that density command? Again, the screen will morph and match now the new constraints, and your screen is forever broken and looking ugly. No. Don't panic, you can use WM reset to go back to number 1. Why am I telling you this? Simply because if you need to test on a device with a very specific screen orientation and you don't have access to that physical device, and 2, you're lazy like me and don't want to set up an emulator, which is probably the preferable route, then you can go to the internet and be like, oh, Pixel 2 has got this resolution, this DPI, plug it straight into those commands, and you're seeing what a Pixel 2 would look like on your screen right in front of you. Maybe interesting. Number 3. Starting an app without knowing the activity. This is very bespoke. I find this incredibly useful. You might. I'll tell you about it. If not, just ignore it. We can use AM, or Activity Manager, to start activities on our devices. Hopefully you're aware of that. We can pass -n for component, pass it a package ID, and then an activity that we want to start. But what if we don't know the activity? What if we're not the original author of this app, and we don't know that? We can't just pass it package, because that'll complain it won't work. So instead, we look to a tool that shouldn't be used for this, ADB Monkey. ADB Monkey is an application stress testing tool, which I'll talk about in just a second. But for now, Monkey can solve this use case very easily. ADB shell monkey -p for package, pass it the package we want to open and the number of events we want to trigger. In this case, 1. Just open it. Open it and bugger off, Monkey. Cool. However, whilst we're here, let me talk about ADB Monkey just for a second. ADB Monkey is as though I've passed my app to a monkey and just said, go, and the monkey's like, blah, 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 blah. And you can see if your app withstands the barrage. It's really quite interesting. Here in this command, right at the end, I've given the number 5,000. I've said, hey, monkey, do 5,000 wacky, crazy things, and I'll watch and see if my app falls over, and I get nice logging out from it. It's random crazy stuff, although I have passed a seed ID, so if it does fall over during the stress test, and I'm like, oh, it's fallen over, let me fix it, I can run the exact same sequence again with the seed ID to see if I fixed it. Very, very cool. Just try it. See if your app withstands the barrage. And finally, permission testing, the last one, and then you're free to go to lunch, I'm sorry. It's not really permission testing, this is a terrible title, but it's basically tweaking with permissions from the terminal. Often we'll have apps that have these runtime permission dialogues that say, hey, can I do this? Can I post notifications? Yes? No? OK, fine. But we can answer this question from the terminal without even opening the device. We can use package manager PM grant, passing it a package ID and the full name of a permission. In this case, it would be android.permission.post notifications. And that's as though the user said, yeah, you can do that. Or we can do revoke, which is as though the user's gone, nah, don't do that, disallow. But the one that I think is most important is clearing up any previous answer to that question, as though the user has not yet answered that question. And hopefully, once you've run that command, you can see if the user gets the dialogue again or if there's something more nefarious at play. Oh, awesome. We've done it. We're at the end. Last 2 slides. Here we go. I wanted to talk about like 1,000 more things, and there's loads more to talk about. So here's some quick honorable mentions. Everything in this slide as well is also included in the link tree. Screen copy, top left, for example, is a really great tool to mirror your physical device onto your desktop computer. JQ is a terminal JSON parser. There's some really great ADB GUI tools there. There's even IDEA plugins for ADB. Really, really great stuff. Some fantastic developers. A lot of open source stuff there as well for you to investigate. Oh, thank you, everybody. That was a hell of a ride. Thank you so much for your patience and your energy and your support. My socials are up there on screen. Please feel free to reach out to me. The link tree, of course, is there. That's the one link you really need to keep hold of. And of course, if you like my stupid, ugly face, or if maybe you're a fan of the channel, I've got a couple of stickers, small and big, for you to just come up and grab. Thank you very much. If you've enjoyed this talk, If you've enjoyed this talk, thank you.